Hey guys, it's Lemar. Today I'm going to be explaining the Physics Week 10 quiz for grade 10S. The questions are repeated except if you were IG. You didn't see those questions. Inshallah, the exam comes like last time. Last time the exam came, like almost copy paste. Okay, let's get started. So here we have to know that this will give us constructive. Okay, so if it's constructive, we need to have the answer as a whole number. So this is decimal, okay, this is a decimal, and this is neither, so we're gonna cancel them. Those are whole numbers, so we take them. Okay, now, question number 4. This question, look, first thing they want similar size to Earth. Now here they said compared to Earth. يعني here they put you a set of numbers. Now, you have to look at the smallest, 0.38. يعني there's a very small difference, which means this is the closest, like similar size to Earth. Okay? Now, least orbital period, it means the closest to the sun. So you go and look. You have to look at the least number, which is 0.39, which is in Mercury. Okay? Yeah. Mercury. Oh, my bad. For part A, Earth is 1. Okay? We have to know this. The closest is 0.95. Sorry about that mistake. Okay. Part C. The greatest tilt. You have to look at the tilt. Look here, it said tilt. They said greatest. So you go and you look at them. The greatest is 177, which is Venus. Okay. The planet that takes the least time to rotate. It means like the least rotational period, which is 9.9, which is Jupiter. Okay, question number 9. صراحة, I don't know why they put for us the solar system. I hope it's gonna be easy. We're just gonna try as much as we can. Using Hubble's constant, this estimated age of the universe to one decimal place is how much? So, the T is equal to 1 over the H. The H, we have it. It's here. Okay? I think, according to ChatGPT or something, it said this is how it's supposed to be. Okay? So you put it. It's 4.55 times 10 to the power of 17. This is in seconds. Now we have to make it from seconds till years. You have to divide by 3.15 times 10 to the power of 7. So this over 3.15 times 10 to the power of 7, you get 1.44 times 10. Okay, and then you make it to exactly how it's supposed to be. It's gonna be 14.4 billion years. Okay. This question, it came before copy paste. So you have to convert them. This I forgot to write it here, but it's gonna be, I think, 0.6 times 10 to the power of negative 2. Okay, you solve it, you put tan y over L. Okay, you do this, and then you put on the calculator shift tan. You get this. You get it approximately 4.6. Now, remember this formula. This formula, you have to memorize it by heart, because most of the exams okay, you do it. Look, the D, like I said here, the sign is 4.6 from the angle we got first here. Okay, and then over the 5, which is, look, they said fifth order, which means m is equal to 5. You get this, okay, as meters. Now I have to make it nanometers. So you multiply by 10 to the power of 9. So 6.641.6. Okay, nanometer in nanometer. Now 19. Lambda equals to V over F. So 340 over 680. Okay. 0.5. 0.5. Now, RQ minus RP. We could also say final minus initial. So 2 minus 2.5 is equal to negative 0.5. Now, absolute value 0.5. Now, this over this, 0.5 over 0.5 is 1. Okay? Now, like I said before, constructive interference has to be a whole number. It cannot be a decimal, it cannot be this. So, because it's a whole number, it's constructive interference. This question also came copy-pasted in the exam. Okay. The wavelength of the laser light used in the experiment to the nearest integer is how much? So like I said, this formula. Okay. Just make sure everything is 2 meters. Here I converted it from micrometers, I think, to meters by multiplying by 10 to the power of negative 6. And we know, m is equal to 4 because they said the fourth order bright fringe. You get this in meter. You have to multiply by 10 to the power of 9 to get it in nanometers. Okay, you get 809.9 meters. Now you'll make it 810 nanometers. Oh, okay. Also part AII. This again. So d sine over lambda. Lambda, we got it here as the meter. Look, as in meter. You keep it in meter. Okay, and then sine 90. This again. And you get 37.04, so 37. Now we need to find the total number of fringes. So you use 2 times max plus 1. So you do it and then you get 75. Okay, question number 23. Okay, you have to use this formula, but now since you need to find the lambda, this is how you use it. Okay, something my teacher told me, always use the smallest, what's it called? Yeah, the smallest one as small d, okay? So, 1.4 times 10 to the power of negative 3, this is after converting them, times 1.1 times 10 to the power of negative 3 over 2.2. You get 7 times 10 to the power of negative 7, okay, meters. Now, you have to make it nanometers, so it becomes 700 nanometers. This question. Okay. The intensity of the transmitted light through the series of filters. We have two. One at 30, one at 60. So, the one at 30, they said it's 15. So 15 cosine 30 squared. 11.25. Now we use this 11.25 and we put it here. You put the same formula, cosine but 60 squared. So 2.8125, so 2.8. Then you minus both of them, you get 8.45. So approximately 8.5. So here in the options, 8.4. Okay. C equals to lambda f. Okay, so we know that c is 3 times 10 to the power of 8. Lambda times 8.57, they give it to us. Here you're just basically finding lambda. You find it, you get like 3.50058, okay, times 10 to the power of negative 7, like we always do and like they always want in nanometers. It's not always like that, but most of the time, from what we are taking now, you have to make it nanometers. So you multiply by 10 to the power of 9, and you get 350 nanometers as your answer. The last question, number 28, this one also came copy pasted. Look, here we have 1, 2, 3 dark fringes, okay? And they said those 3 are 5.4. So the spacing between consecutive bright fringes is how much? 5.4. The 5.4 here divided by 3. So you get 1.8. Okay guys, this is the end of the video. If you guys have any questions, you may ask me. And thank you guys for watching.